The acceleration of a particle as it moves along a straight line is given by a equals 2t minus 1 meters per second square, and it's asking for velocity, position, and total distance, which means we need to start from a of t and integrate all the way down to s of t, and check along the way if v equals to 0 anytime before t equals 6. Note that all the required initial conditions are given in the problem: S naught, V naught, and T naught. The first step is to find the velocity at t equals 6. This is easily done by integrating a of t with the given initial conditions V naught and T naught to find V, which is found to be a quadratic equation in t. Substituting t equals 6 gives us the velocity after 6 seconds, which is 32 meters per second, and this is the first part of the question. The second step before going to s of t is to check for any turning points which causes v to be equal to 0. A quick test on v of t shows that if t equals 0, v equals 2. And this is a very important validation of our initial condition. Then, v of t increases in the positive sense. So, at t equals 1, v equals 1 minus 1 plus 2. So, v is still equals to 2. But at t equals 2, v equals 4 minus 2 plus 2, which is 4, and it increases with every increase in time. This means that v of t will not be equal to 0, and therefore delta s is always the distance traveled. As a result, we'll integrate v of t using our initial conditions to find s of t. And now we're ready to find the displacement, which is equal to the distance traveled by subtracting the final position when t equals 6 from the initial position when t equals 0, which is 67 minus 1, and it is equal to 66 meters.